Hi everyone, it's Coach right here, and we're going to be talking about more involved linear equations. And I want to go back for a second to talk about equations that have no solution or are the identity. So the identity property means like anything equals itself. So A equals A, or segment AB equals segment AB. So basically you have an equal expression equaling an expression that are exactly the same, or they work out to be exactly the same. Sometimes when the result is the identity, we'll say that the solution is all real numbers. All real numbers. That means every x value can be plugged in and you will get a true statement. Sometimes we write that using this funky little symbol looking like that. That means all real numbers. Sometimes we might even write it as negative infinity to infinity, like that. But that means that every number you can come up with that's real is going to make this true. All right, so I'd like you now to take what I just said and write down what you'd like to define as an identity. And then see if you can give me an example of an equation that is an identity. Don't use the ones I gave you. Make something up that's a little bit more involved and see what you can. See what you can do. So, and bring that to class tomorrow. All right, but let's talk about if we can determine whether each equation is an identity or it has no solution pretty quickly. So when we look at equations to solve, I see here that I have an expression, so I have to simplify it. So I'm going to distribute the 4. So 12m plus 16. I'm going to do the same thing on the left side, and I'm going to get 12m plus 16. Now, I could go on to solve that, but I'm hoping that you see that you have the exact same expression equaling the exact same expression. So this would be the identity. So all real numbers, negative infinity to infinity, meaning every solution is a solution. And we could actually test that out. Give me a number. Let's say m was 5. So 12 times 5 is 60 plus 16 is going to be the same as 60 plus 16. All right, let's look at this next one. 5x plus 2x minus 3, so I have an expression equaling an expression. I'm going to combine them. It's going to give me 7x minus 3 equals 7x. So right here, I see that I have 7x and 7x. But this one I'm subtracting 3 from, and this one I'm not. So this is a case where the equation is not true. So that would be no solution, which we can write like that. So I really want you to be able to look at these without having to solve them to identify if they're the identity or if they have no solution. So what I'd like you to do is try C and D and bring those to class tomorrow for us to go over. All right, let's go on to something basic equations that involve absolute value. All right, so the other day in class we were talking about the idea of absolute value, those funny bars. They look like ones. If I put -2 in absolute value bars, you all could tell me that those bars made what was ever inside positive. And that was actually true. So if I take the absolute value of a -2, my output, or my equals, is going to be 2. Now, we did talk a little bit more about absolute value being distance from 0 on a number line. So the absolute value of -2 is 2 units away from 0 on a number line. Okay, now more involved equations, first we want to always isolate the bars. So there's those absolute value bars. We want to isolate them, so just like we would in a regular equation. So we're going to add 2. Now I want you to think about that a second. The absolute value of y equals 10. We're solving it, so we're trying to find the value of y. So hopefully you see that y could actually be 10. But I also want you to consider that y could also be -10. So when you're taking the absolute value, the algorithm for it, or the recipe for solving, is to take whatever's inside the absolute value and set it equal to both the +10 and the -10. But in this case, it was kind of nice to see it written like that. All right, let's try this one. The absolute value of x plus 6 equals 3. So first we want to isolate the bars. So we're going to subtract 6. And we get the absolute value. Let me fix that. Let me use black. The absolute value of x equals negative 3. That's a very interesting equation. I'd like you to think about that one for a second. What value of x can I put in there and then take its absolute value that's going to output a negative 3? I hope you're saying it's not possible, Coach Fred. There's no way for me to take the absolute value of a number and to get an equals or an output of a negative 3. So in this case, this is a case where it's no solution. Now you got to make sure that the bars have been isolated first. But once that's true, think about it. There's no number that I can, if I put in negative 3 for x, I take its absolute value, I'm going to get 3, not negative 3. So you can see clearly why this is not a possible equation. All right, guys, that's it for today. Hopefully you have a great day. Talk to you soon.